Alright guys, welcome to class today. We will be continuing on with our equations. Today we are actually moving from graphing just a single equation into a XY coordinate grid into graphing multiple linear equations into that same grid. It is called a system of equations, and we're going to determine by the graph of those systems what the solution to those problems are, and on top of that how to identify the number of solutions in a system of equations. So today's I can statements are on the board. It says today's I can statements are: number 1, solve system of equations by graphing, and number 2, identify the number of solutions to a system of equations, whether it be 1, infinite, or none. Alright, we're going to begin class today with our typical start. We have a few bell ringers here that we must answer, and they are all drawing back on our past knowledge that we've been gaining in this chapter. The first one, it asks, find the slope of a line perpendicular to the line whose equation is 3x minus 7y is equal to 6. If you remember, we've been talking about two different forms. You have a slope-intercept form, and we talked about that being y is equal to mx plus b, where m is our slope and b is our y-intercept. We also have the point slope form, which is y minus y1 set equal to our slope multiplied by x minus x1. And we also talked about, if you remember in class, we talked about slopes, and we said that if a slope happened to be parallel, that it will be the same, and then if slope is perpendicular, that it will be the opposite reciprocal. Okay, so we need to get this in a form that will give us a slope. So looking at it, we need to move the 3x term to the other side. We also need to get the negative 7 away from the y. So we can do that by using two steps. First, subtraction with the 3x. We get negative 7y is equal to negative 3x plus 6. Again, that is found by subtracting a 3x, subtracting a 3x. We then want to divide both sides by a negative 7, and if we do so, our left side now has y set equal to negative 3 over top of a negative 7 would give you just a 3 over 7x, and then positive 6 over negative 7 would give us a negative 6 over 7. So if you remember, this is our slope, this is our y-intercept. We are asked for perpendicular. Since we're asked for perpendicular, we need the opposite reciprocal of what is given to us. So 3 over 7 is given to us. If you remember, the opposite reciprocal is the same as saying flip the sign or change the sign and then flip it. So this is a positive. Let's change its sign to be negative. And then if we were to flip 3 over 7, we now have negative 7 over 3. So answer to this one, the perpendicular slope, negative 7 over 3. For the second one, find an equation of the line that passes through the said point, negative 1, 5, and is parallel to the line y is equal, but y minus 5x is equal to 1. This is where and why we talked about point slope. It'll be a lot easier to use that here. Let's find out the slope that the problem is given. So if we move the 5x, we would have y is equal to 5x plus 1. We know that we're dealing with a slope of 5 here. So we need parallel. We want to use that same slope. Now let's plug in our point into point slope. So y minus y1 would be a 5 here. Use the same slope that is in the problem, which is a 5. Now remember, in our formula is x minus x1. Well, when we are subtracting a negative like we would be here, so anytime you subtract a negative, it will change that to be a positive. So I'm going to go ahead and put plus 1 here, and we have done what the question asked. We have found an equation of a line that passes through this point and is also parallel to the line given. All right, we'll go over a few examples of what this looks like. Again, we have been graphing single functions, single lines in XY coordinate grid. So now we're just going to be graphing multiple in the same. So looking at example 1, we have been maybe graphing these independently, not on the same graph, but this is a slope of -1. Remember that should be going down and to the right with a y-intercept it looks like of a +3. Your second equation has a positive slope, so it should be going up and to the right. It is a +4 and y-intercept of -2. So we have graphed that particular function here. Both functions are listed in the same one, so again this is referred to as a system, and the solution to the system will always be where your two lines intersect. So it looks as if my two lines intersect at 1, 2. You can see that they intersect there. So my solution to this particular problem would be x1, y2, meaning that if you plug these in to both of these equations, you would get the same exact answer. So plugging in the 1 in for the x, you would have -1 plus 3. -1 plus 3 would give you a 2, so therefore you'd have 2 equal 2, which would be a true statement. Moving down to the second one, if I plug the 1 in here, 4 times 1 would give me the 4, minus 2, which again is 2, so 2 equal 2, true statement. So I know that I've done this one correctly as far as graphing is concerned. Looking at another option with these, if you look and you happen to see that the two equations are the same, so again, this is what the system started out looking like. The first equation was already in slope-intercept form for us, so that would have been easily graphed, which we have done already. Looking at the second one, it is not already in slope-intercept form, but by rewriting it, again, we are able to go down and see that, okay, this looks to be exactly the same as the first one. So therefore it would be the exact same line. Okay, so the exact same line, you're saying, well, how they intersect everywhere. They don't intersect only at one point, they intersect everywhere. So since they intersect everywhere, the solution to this is infinitely many solutions. So you've seen an example of when they intersect. If they intersect, then that means that there will be one and only one solution. You've seen an example of, again, where it's the exact same line, which is infinitely many solutions because they intersect everywhere. The third one, again, here both of them are not in slope-intercept form, but when you get y by itself, both of them are 2 steps. You would be subtracting the 18x, then dividing by -3. For the first one, the second one, you only have to do 1 step by dividing the -1 out on both sides. You see that both equations are the same. So again, you found yourself that, okay, this, if asked how many solutions, is it 1, 0, or none, you would again have the same solution of infinitely many solutions. I know that we have graphed plenty of these leading up to today. The only one that you have not seen is if the slopes happen to be the same as they are here, but the y-intercepts are different. If that happens, I left this graph for us blank here because you would have, let's say, a line going here, a line going here. You have slopes that are the same, but the y-intercepts are different, so therefore, if asked, will these ever cross? The answer to that would be no. So how many solutions would be in this particular example? You would say there would be no solutions for this one. Okay, So you have the options, and the only options of you have one solution and you can find it. It will be where it intersects. You have infinitely many because it's the exact same line. Or with our made up example here, they will be parallel lines and it will be no solution. All right, to end, right before you all start your homework today, we're going to do an ACT standardized test prep problem. I've already got it kind of started here for you. It is multiple choice. How many solutions does the system have? We need to write both of these in slope-intercept form, if possible. The first one I have already did for us. It was a one-step. You just subtract the 2x over to get y is equal to negative 2x plus 3. We now, for the second one, want to get this y by itself, and then we will look at the two formulas that we have come to and see if we can determine anything. So if we subtract the 9 first, 6x minus 9 is equal to negative 3y. If you divide by the negative 3 now, you have negative 2x plus 3 is equal to y. Those of you that may want to rewrite this, again, y on the left side, you just bring y to the left side, keep everything else the same. Before we even wrote these two out, I would hope by looking at our answer choices that we could eliminate one of them. If you could eliminate the last one, it would be great. I say that because, again, we were talking about there's only 3 possibilities. There'll either be one solution. Remember, this is when they intersect and cross, and we can find that point of intersection. There will be none. That means the two lines given are parallel. They have the same slope, different y-intercept, so they will not intersect. Or infinite, because it's the exact two same functions, and so it'll be the exact same line, and they cross infinitely many spots, so infinitely many solutions. So D, I hope that we could mark out. And then when looking at our two problems, we have same slope, we have the same y-intercept. This tells me that these two functions are the same. Since they're the same, they will cross infinitely many spots, so the correct answer would be C, infinitely many. Thanks for watching. If y'all have any questions, let me know. You all can now get started on your homework.